this is a master program, which is an official master program. I'm going to tell you a little bit later. Let's say the motto of the master program is skills for a better future. So the idea is we don't want to have a program for you in a really highly specialized discipline. We want you to get stronger as an engineer or as a scientist, as in engineering, to work in projects that are interdisciplinary, innovation projects, and so on. Okay, so that's basically the aim. For any questions you have, this is my email, and you can just send me an email and ask me questions if you want. So I'm open to your questions. So this is basically the highlights of the master program. It's a master program. It's an official master program at the UPC. All courses are going to be taught in English. That's why the presentation today is in English. So our aim is to have students from everywhere in the world. It's actually like that this first year. So half of our students are coming from very different places of different countries. And the program is a 2-year program. So you are going to have 120 credits to complete the program, and a final master thesis, which is included in this 120, of course, of 30 credits, which is a lot, actually. I mean, it's not a lot, but it's a strong point of the master program that you develop an innovation interdisciplinary project in an area that is of your interest, okay? So the basic approach is, let's say, 21st century engineering. So we want you to have strong skills in what is coming, like digital age, simulation, artificial intelligence, and things like that. So it's basically like approach of engineers that work in innovation and research projects. And basically you're going to have, the master offers you 3 specialization areas, and they are covering most of what we consider the future of technology. One is energy, and we are covering in energy, not only energy, but also sustainability and green engineering and so on. Industry and advanced manufacturing process, like in plants and more industrial, let's say, orientation. And then healthcare and biomedical applications. Okay, so this basically the highlights. You see the picture here represents people cooperating together for a project and for a common aim. And this is basically what we want to teach you or to provide you as a basic skill in the master program. Okay, so first thing is, why do we need another master program at UPC? We have plenty of them. If you go to the webpage of Masters at UPC, you'll find many options, and they are all really good. So the idea is, why do we need another master program here? So my answer is, if you want to specialize in a really particular area, like, I don't know, power electronics, or I don't know, artificial intelligence, or whatever is your area of interest, like construction, whatever, you are going to most likely find a really good master program at UPC. And my advice is, if you have a really clear orientation and you want an in-depth specialization profile, then just go for a master that offers you that. Or master program is offering you a different profile. It's this one, actually. So the idea is there are other in-depth specialization studies at the master level that provide you these deeper skills, like in robotics, chemistry, material science, and you name it. Okay, so this master program that I'm talking about today, it's not defined to make you more specialized. It's oriented to make you stronger, better in working in engineering interdisciplinary innovative projects. Okay, so after all, our approach is, you already got your degree. So you are an engineer, you are a scientist, you are a mathematician, whatever you got from a bachelor profile, that's what you are, and you are assumed to have strong skills in your area. Okay, so the idea is that we are going to provide you with knowledge and skills because technologies are going to shape the future, and if you want to participate in this transformation, this is going to be important that you have these new skills. So how are we going to do that? So in order for you to acquire this, what we consider these 21st century engineering skills, that includes sensors, instrumentation, computer simulation, machine learning, analysis of risks, computer vision, many things that you are going to see in my presentation. Then we packed what's important for you, and then we put it in the master, okay? And then once you have these basic skills, you are going to apply these skills to an emerging area of your interest. So you have to define whether you are more interested in energy efficient systems and sustainability, or in more smart factories, industry 4.0, advanced manufacturing area, or if you are more interested in applying your new skills to healthcare applications and biomedical area, okay? So the idea is you are going to get better, and then you are going to specialize in an emerging area, and then develop innovation projects in this environment of interacting with many other people from different profiles, okay? So why is that interdisciplinary and innovative? Because we know you already have many skills in an area, and you can as well get a job in that area, because you are, I mean, you are skilled for that. But innovation projects require integration of different profiles and technologies. So normally an innovation project will require some mechanics, some material science for selecting a material, place sensors in a structure, do some control, do some analysis, data analysis, and so on. So when you are working as an engineer in an innovation project, most likely you are going to be interacting with different profiles with a common aim that, let's say, overwhelms everyone in the table, okay? So that's why we want to, our focus is to develop skills in this context of interdisciplinary innovative projects, okay? So, of course, you need technical skills, but you need some other skills that are also important. So you need to do management of technological projects. And this is not like something you add on top of your career. It's something you have to do. It's something that every day is going to be more and more important. You need to know how to get funding for a project, how to sign legal contracts with your partners and your colleagues and your companies, and you need to deal with intellectual property and rights and patents, things like that. You have to evaluate the risks of a project. And some risks are technical, some risks are just commercial, some risks are personal interaction between the people involved in the project. And you have to, let's say, take into account all this, and these are really important things for your project to evolve in a proper way. And of course, you need to do how to do innovation, how to deal with financial aspects of your project, how to take advantage of other projects in a context of circular economy, and how to provide information in social and networking media, get context. Of course, you need to do all that. So if you better get prepared for that, because otherwise some other people not skilled like you in technological problems is going to do that. So you better get prepared for that, okay? So in the master program, some of the skills are going to be oriented exactly for that kind of management of technological projects. The teaching methodology I'm going to talk later about the structure of but the teaching of the master. The teaching methodology is going to be the following one. Basically, every of the courses that you are going to take, it's composed of an interdisciplinary team of faculty. So professors are going to be mixed up. So like in the course I'm coordinator is about machine learning and data analysis. So we have some people from computer science, some people from systems engineering, and some people from mathematics. And we want you to have this exposure of different profiles in every topic. So this is our teaching methodology in the master program. And then, of course, you are going to combine theory with practice and teamwork, as we do in many other master programs. We are going to have seminars by external experts from companies and research centers, telling you what's going on in the real world. Let's say I'm an academic, so I do research and teaching, so I'm not working in a company. I don't know many things that they do, so I invite them to come to my class and tell you about this information. And of course, it's going to be focused in acquiring skills. We are going to avoid tons of deliverables, so the idea is not to overwhelm you with lots of reports, but to take like only the value that you can add in every project. Of course, we are going to have some collaborative platform to share codes between your colleagues and mates and so on. So the curriculum is basically 2 years. First year is devoted to core skills and management skills. So you're going to have 36 credits for these core skills. I'm going to review them now, and 24 credits for management skills. This is at the very beginning. And then once you get this first year, you can choose your specialization block in the second year, which is first semester for that specialization track. And the last semester is totally devoted to final master thesis, okay? So that's basically the structure of the master. It's pretty simple. If you want to go into more detail, this first year, so every row is a semester. First semester, you're going to attend to a data acquisition and instrumentation course, data analysis and pattern recognition, systems modeling, simulation and optimization, and technology innovation. So this is what you're going to do in the first semester. Second one, you're going to go a little bit farther with control systems, computer vision, risk analysis, circular economy and sustainability, and management of technology, okay? So this constitutes like the basic skills that we want you to acquire before electing one of the 3 tracks that you see here. In the third semester, you're going to choose one of these 3 tracks, and you need to choose a total of 5 courses. And how it works is, if you choose one of the tracks, you can choose either 5 courses from the track or 4 courses from the track and 1 course from the other 2 tracks, okay? So that's basically the idea. The energy efficient technologies includes our renewable energy systems, electrical energy processing, sustainable materials, fuel cells, and electron beam applications. So it's basically oriented towards energy and sustainable applications. Smart factories is going to be advanced manufacturing, mechatronics, Internet of Things, sensors and micro electromechanical devices, plant monitoring and fault detection, and robotic systems. So it's more for plant, let's say, oriented engineers. And the third one is healthcare biomedical. You're going to have a course on biomedical signal analysis, biofunctional materials, bioinformatics, wearable devices, and biomechanics, okay? So just to make that clear, you can take the healthcare, for instance, track, and then take one of these courses out because you are more interested in, I don't know, maybe robotic systems. And then you take that course in addition to the 4 courses you choose from the healthcare, and then you can do this kind of combinations for the optional courses, okay? And then the last one is a final master thesis. This is fully devoted to the master thesis. We are going to develop that in research centers and innovation centers we have a collaboration with, and let me tell you a little bit later, okay? So core skills is getting data, analyzing data, model systems, simulate them, control them, enhance your product with some computer vision and virtual reality, things like that, okay? And then the management skills is identify risks and how to manage them, be more efficient and sustainable in your projects, and manage some projects, okay? That's basically the idea. And then the 3 specialization blocks, I'm not going to be really in detail about that, but we identified that today's society demands these breakthrough technologies in really key emerging areas. And these key emerging areas are energy, industry, and health. Okay, so you know, world is going to demand professionals, and in particular, high-skilled professionals in technology in these 3 areas, and this is going to be like that. I'm not saying that, it's Bill Gates saying that. So we took that idea, and then we let's say constructed these specialization blocks to offer that demand to these 3 topics that we understand they are going to be important for you. Okay, for your future. In efficient systems, of course, this is a little bit more in detail, the contents of every of the courses. So you have this energy, electrical, how to deal with energy, how to store that, how to harvest that, how to use solar energy, wind turbines, and microgrid, things like that, how to select materials in a sustainable way, how to work with fuel cells and electron beam applications. So this is basically the contents a little bit more. You're going to find that in the presentation, the slides, so I'm not going to go in more detail. Second one, it's advanced manufacturing. And of course, you get this additive manufacturing process, advanced characterization techniques of materials, quality control, and so on, mechatronics, how to integrate mechanics and electronics in the same device, how to develop sensors in a micro structure, so to place them in different places, how to monitor a plant, like a plant or a process, and detect faults by placing monitors and controlling how they evolve, and of course, how to work with robotic devices, okay? So this is a little bit more in detail, the contents of the advanced manufacturing. The healthcare and biomedical applications is basically working with signals. So, you know, in biomedical area, you get lots of images and signals and data from your subjects. And so you need to work with biomedical signal analysis, with biofunctional materials. So you need these materials to do drug delivery, for instance, or for do coatings for special applications, or for to extract information from a certain 3D model of your organ, whatever. Okay, so bioinformatics is how to work with genomic data, sequence alignment, and drug design, for instance. Wearable devices, you have probably a wearable devices with you, either a watch or a activity monitor, things like that, and this is going to be more and more in the future. And then the last one is biomechanics and sport technology, which is basically multi-scale biomechanics, movement control, motion capture, camera, and so on. Okay, so of course, I don't have to tell you that the specialization tracks are not providing you a really in-depth specialization. So if you want to work with robots and you have a clear idea, you want to work in robotics, this is not your master. You have to go to a robotic master program and then get an in-depth specialization. But if you want to work in an innovative project that involves robots, you need to know how to program a robot, how to interact with that, how they can do for you, and you need to know a little bit about that, and that's what we are providing you, okay? So highlights of the school, I'm talking briefly about the engineering school that offers that program in UPC. It's East School of Engineering. This the youngest campus among all campuses in UPC. It's only like a few years old, but we are young but really strong. So I'm just showing off a little bit. This is like a ranking of the different campuses, and we are on top of it, the second on total production in research production. So we are a young campus, but we are strong. This is not total production because we are a big campus, but this is the production divided by the number of researchers in the campus. So this is showing a little bit the muscle we have in terms of research and innovation projects, okay? So we have a strong collaboration with companies and research and innovation centers in different areas, from advanced manufacturing to hospitals to different universities. We do have recently signed a double degree for those students interested in doing like a double degree in international double degree with the University of Genova. So you have this option of studying the first year in Barcelona and second year in Genova, and we are going to have more and more options in this internationalization options in this sense, okay? These are basically the highlights of the research school. And I don't have to tell you, this is a very digitally oriented master program. So most of the techniques we are going to work with are computational software tools. The idea is you are going to be exposed to a variety of digital and software platforms, but basically Python is going to be like the language we are going to use, like a structural language for all courses. But then, of course, you need to work with specific pieces of software to deal with other projects in mechanics or in programming robotic systems or to simulating a system, okay? So this is basically somewhat like a survey of the most common software tools you are going to be faced on during the master program. Let me briefly say something about the admission. That's basically for students interested. Specific requirements are you need to certify a B2 level of English. If you got your bachelor degree in any Catalan university, you have that with your bachelor. But if you are not, then you need to prove that B2 level of English. You need, of course, a university level qualification from a scientific technical nature, that is either engineering or mathematics or physics, in scientific or technological profiles. And then the admission criteria for students is 60% is your academic record. So our intention is to capture top students from universities all around the world. And the second one, it's correspondence between your profile and the profile of the master degree. It's 40%. Okay, so this is basically the information about the admission.